देखो यहाँ पे एक रॉड है, एक रॉड है जिसका मास m है और लेंथ l है, लेंथ l है, ठीक है। ये पॉइंट A है, ठीक है, एंड ये पॉइंट B है, ठीक है। इसका वेलोसिटी है 2v0, 2v0, और इसका वेलोसिटी है v0, ठीक है, v0। अभी देखो स्टूडेंट, हम क्या करेंगे, समझो एक रॉड है, ठीक है, एक रॉड है, ठीक है, एक ऐसा एक रॉड है, एक पॉइंट फिक्स है, एक पॉइंट फिक्स है, एंड दिस रॉड इज मूविंग, it is performing rotation motion around this point. तो a लेंथ समझो l है, तो इस पॉइंट पे टांजेंशियल वेलोसिटी क्या होगा, अगर दिस पॉइंट इज b, so velocity of b point, tangential velocity of b point is equals to let us suppose it is rotating in triangular omega triangular frequency l omega, ठीक है। And if we take the midpoint of that particle, so what is the tangential velocity of this particle? L omega by 2. So this point is A. So tangential velocity of point A is equals to L omega by 2. Same is the case. If L into omega is equals to, if L into omega is equals to V0, if L into omega is equals to V0, so this is V0 by 2. Or we can consider in either way. So I want to say that this velocity is twice of this. If this is V0, if this is V0, then how much is the L omega? L omega by 2 is V0. How much will be the L omega? 2 is 0. Same is the case. And this is called as instantaneous axis of rotation. This is called as instantaneous axis of rotation. That means this rod is performing pure rotational motion around the point 2L. Not getting it. Get it, not get it. Yes, no. Okay. Now, how to find out the answer then? Okay. How to find out the answer? Okay. तो यहाँ पे देखो अभी क्या है, the kinetic energy of the rod. Simply the kinetic energy of rod, the kinetic energy of rod will be half r into omega square.
Sir, the body rotational plus translational perform करेल, कारण त्यांच्या वेलोसिटीजमुळे ती जात राहील पुढे आणि रिलेटिव्ह वेलोसिटीमुळे रोटेशनल मोशन करेल.
Yes. It is same. Now let us suppose this is a sphere. This is a sphere. It is performing pure rolling motion. Okay? It is performing pure rolling motion. So this particle is having velocity v, and this particle, they are having different velocities. So what is total kinetic energy of this particle? So this velocity is equals to r into omega. So what is total kinetic energy of this sphere? Half m square plus half I omega square. ठीक है? And this omega is equals to v by r. So that is equals to half m square plus half. What is I? About this point E. 2 by 5 m into omega square. V square by r square. So how much is this calculation? How much is this calculation?
7 by 10.
Yes. V square by r square. v square. Okay? So we have considered here translational as well as rotational. Now we will find out the instantaneous axis of rotation in this case. We will find out the instantaneous axis of rotation in this case. So how to find out the instantaneous axis of rotation? Draw the perpendicular to every velocity. So here are two velocities. One is translational, one is tangential. The resultant velocity will be like this. Here are two velocities. One is translational and one is rotational, and resultant velocity will be yes. This one 45 degree. Yes or no?
Yes.
So we will draw perpendicular to this velocity. So this is the perpendicular to this velocity. Then again we will draw perpendicular to this velocity. Here is also this is one velocity and this is one translation velocity. So this is our resultant velocity, and we will draw perpendicular to this also. So this is the instantaneous axis of rotation. मतलब इसको हम ऐसे बोल सकते हैं कि ये जो स्क्वायर है ये पहले ऐसे था, बाद में ऐसे हो गया, बाद में ऐसे हो गया, बाद में ऐसे हो गया. And in this case no need of translatory motion because this translatory plus this rotatory is equals to about instantaneous axis of rotation. This translatory plus this rotatory is equals to rotatory motion about instantaneous axis of rotation. Translatory plus rotatory is equals to rotatory motion about instantaneous axis of rotation. So no need to consider the translatory motion if we are considering the rotational motion about instantaneous axis of rotation. Here, no need to consider the translation motion if we consider the rotational motion about instantaneous axis of rotation. In this case also you will get the same answer 7 by 10 in v square because I will change. That is equals to half. How much will be the I? Because this is the instantaneous axis of rotation. How much is I? How much is I? 2 by 5 plus m square.
7 by 5.
7 by 5. So half into 7 by 5 m square into
7 by 10.
so it will extend omega square v square by r square. So r square cancel 7 by 10. Because and how to find out the instantaneous axis of rotation? Simply draw perpendicular to any velocities. Draw resultant velocity, any velocity to take velocity of this point and draw perpendicular to this point. Now all velocities will be intersecting at one single point. They will be coinciding. Or perpendicular, all normals of all velocities will be intersecting in single point, and that point is nothing but instantaneous axis of rotation. And if we consider the instantaneous axis of rotation, no need to consider the translation motion that because if we are considering the instantaneous axis of rotation, it means at that instance particle is performing pure rotational motion about that point. If we consider the instantaneous axis of rotation, that means that particle is performing only rotational motion at that instant about that point about which we are finding the instantaneous axis of rotation. जब हम इंस्टेंटेनियस एक्सिस ऑफ रोटेशन की बात करते हैं तो जो पार्टिकल ट्रांसलेशनल प्लस रोटेशनल मोशन परफॉर्म करता है, लेकिन हम जब इंस्टेंटेनियस एक्सिस ऑफ रोटेशन की बात करते हैं तो वो पार्टिकल ओनली रोटेशनल मोशन करता है उस इंस्टेंट पे उस पॉइंट एक्सिस के अबाउट. ठीक है, ठीक है. तो अभी यहाँ पे कैसे पता करेंगे? चलो बोलो. हम लोग अभी पैरेलल एक्सिस थ्योरम. ठीक है, वी यूज पैरेलल एक्सिस थ्योरम क्योंकि हम लोगों को पता है कि इसके अबाउट मोमेंट ऑफ इनर्शिया पता है हम लोगों को. ठीक है, सो वी नो द मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस एंड वी नो दिस इज हाउ मच दिस डिस्टेंस इज l because I have explained you the concept. Instantaneous axis of rotation will be l distance from here. This is instantaneous axis of rotation. Okay, so you can find out the moment of inertia about instantaneous axis of rotation, and then that is equals to half. How much is the moment of inertia about instantaneous
31 ml square by 12.
31
ml square by
ml square by
12.
12. So that is nothing but I. Okay. And how much is the omega?
V square by L square.
V square by
L square.
not V square by L square. V square by L square. Correct. So if you consider this V0 square by L square or 2V0 square divided by 2L square, omega square is equals to. You can consider for any point, but you know the tangential velocity is about 2 points, this point and this point, so it will be the same. Okay? So how much will be the omega square then? V0 square divided by
L square.
L square. So this L square get cancelled. So how much will be the answer?
31 mv square by 20.
31
mv square by 20.
mv0 square divided by
Is 24.
24. Okay? So what is the answer for that question? Same, correct. That is the correct answer.